All right, this little video is being shot to help you out with scientific notation, maybe some of the basics related to that, and a little bit of how you do some computation with numbers in scientific notation. So the first question I'm going to try to deal with here is not only the scientific notation, but what is scientific notation? And scientific notation might be something that is written this way, 6.2 times 10 to the third, but really it is a way to handle very large or very small numbers, and often, probably in a normal student's educational career, it's probably dealt with in a science classroom. So when you're in some of the science classes, you might have to deal with a number that's fairly large, or you might have to deal with a number that's very, very small. And consequently, scientific notation is a notation that allows us to handle that very, very well. Now, if we remember, we've been working on exponents, both positive and negative. 10 to the third is really 10 times 10 times 10, which is 1,000. So this problem, even though it's not written exactly that way, is saying what is 6.2 times 1,000? And when you multiply by 1,000, I would hope that we would all expect to get a number that's fairly large, because we're multiplying by a big number. And in this case, it's simply going to slide the decimal 3 spots over. Going by the 2 will be one of them, and then adding a couple of zeros. So 6.2 times 10 to the third is really the number 6,200. Whether that's large or not is up to you. We will have some numbers that are a little bit bigger than that. I think the general rule that a lot of students then come to is if this power is a 3 in scientific notation, it simply tells us we're going to move the decimal 3 spots to the right, which is what ended up happening with the multiplication here. If I take something like, we'll switch this up and let's go with 2.1 times 10 to the negative 4. Before we do anything in terms of moving the decimal, I would remind you that 10 to the negative 4 is really 10 to the fourth, which is 10 times 10 times 10 times 10, and it turns out to be 10,000, and that's 10 to the fourth, and then the negative is simply going to be the reciprocal of that. So this problem, as much as it looks like 2.1 times 10 to the negative 4, is really 2.1 times 1 over 10,000, and I would hope, if you're looking at this, that if you're going to take a number like 2.1 and multiply by a really small fraction, that you would say to yourself, I'm going to get a pretty tiny answer in this case, and consequently that's what ends up happening. The rule here, when we had the positive 3 in the previous problem, it moved the decimal 3 spots to the right. When we multiply by 1 over 10,000, it ends up moving the decimal 4 spots to the left. So in this case, I'll switch colors so we can see this. It's going to go by, which is 1, 2, 3, 4. I'm going to end up with 3 zeros that are going to fill some spaces there. So I'll have 0. There's my 3 zeros and 2, 1. If you notice, that decimal point used to be between the 2 and the 1, and it's now slid 4 spots to the left. So the number 2.1 times 10 to the negative 4 is really 0.00021. And that is kind of the basic idea of handling a little bit of a large number in scientific notation and handling a little bit of a small number. Now, let's do some operations in scientific notation. So in this case, let's look at what we do if we want to multiply. And we're going to take the numbers 3.2 times 10 to the 8th, and we're going to multiply that by 2.0 times 10 to the 5th. First of all, I want to focus on the calculator part of this. Nowadays, with the calculators that are out there, scientific notation or scientific calculators and graphing calculators, these numbers can be handled very easily. I'm going to talk a little bit about the graphing calculator. When you're typing this in, I would simply say to you, type exactly what you see, and I mean exactly. If you see a parenthesis, we need to use the parentheses. On a graphing calculator, if you find the numbers 8 and 9 and go one button up from each of those, you're going to see a button that's got the parentheses on them. Probably the biggest challenge as we work our way through here would be simply a left parentheses, 3.2. We'll hit the time sign on a graphing calculator. It's going to look like an asterisk. We'll hit 10, and then at this point we need to get this 8. And if you hit the caret symbol, it's the button right up above the divide, that is the exponent. And when you hit the caret and the 8, it does something really nice in that it goes 10, and it actually puts the 8 right up there. So as much as you type this, it ends up looking like this. The only problem is your cursor is now located right up there in the exponent. And if I want to get the right parenthesis, which is next, I need to hit the right arrow. And on the graphing calculator, right over here, we've got the arrow buttons up, down, left, and right. We need to touch the right, and when we touch the right, that jumps our cursor out, and it allows our cursor to flash back down on the whole thing. So now we can hit the right arrow. Otherwise, if you hit the right arrow, or the right parenthesis there, excuse me, it will just close out that 8. So using the right arrow allows us to get out of that. Assuming that I do that here, I will then close out this one. I'll type in 2.0 times 10. I'll hit the caret symbol. When I do that, again, I'll hit the right arrow. When I hit the right arrow, it allows me to put a parenthesis. So after both of these, as much as this is written this way, it's really going to end up looking like, it's going to end up looking like an 8 like that. Now, when we do this, the calculator is going to multiply those numbers, and it's going to come back and it's going to give us an answer of 6.4 E, and it's going to say 13. I'd like to remind all students that's probably not an acceptable answer in a class, because this is the calculator's way of writing scientific notation. So hopefully at this point you would convert this and you would say, when I see that capital E, that's the calculator saying times 10, and then whatever number follows, which in this case is the 13, is going to be the number that goes up on the top. So in this case it would be 6.4 times 10 to the 13. Now I want to do one other thing here, and that is I'd like to remind you, if you had that problem, 4 numbers that are being multiplied, 2 times 3 times 4 times 5. If you were multiplying those, you certainly could take 2 times 3 and get 6. You could take 4 times 5 and get 20. You could multiply the results, and hopefully you would come up with 6 times 100, or 6 times 20 is 120. I throw that up there and I say, well, let's take those same numbers, 2 times 3 times 4 times 5, and I'll use a color here so we can see this. But what if someone said to me, you know what, I'm not going to multiply 2 times 3, I'd like to multiply 2 times 5. When I multiply 2 times 5, I come up with 10, and consequently I'll multiply 3 times 4, which is 12, and now when I multiply those results, I still get 120. I put this basic example of multiplying 4 numbers up here to remind you that when you're multiplying, and all you're doing is multiplying, in this case 4 things, you can multiply in any order you want. So if we go back here to this problem, we take 3.2 times 10 to the 8th, 3.2 times 10 to the 8th, and we want to multiply that by 2.0 times 10 to the 5th, and let's say that our challenge was we'd really like to multiply this, and we don't want to use a calculator. Well, if you look at this, here's the number 3.2, there's a multiplication. 10 to the 8th is a number, it's just written in a little bit different form. We also have multiplication here. 2.0 is a number times 10 to the 5th. So I hope, and I'll circle them, there's 1, 2, 3, there's 4 numbers that are being multiplied, and the only thing that's happening is multiplication, so we can choose to multiply in any order we want, which is the case. I could then say to myself, 3.2 times 2, what's 3.2 doubled? That's 6.4. Then I want to multiply my 10 to the 8th and my 10 to the 5th, and we've been working a lot in class about what do we do if we have like bases? Well, hopefully you recognize in this case we have like bases of 10, so we add the exponents of 8 and 5, which then gives me an answer of 10 to the 13th. So I'm going to then finish by leaving one time sign, and I'm going to say that the answer is 6.4, which I got from multiplying these, and times 10 to the 13th, which I got from multiplying my 10 to the 8th and my 10 to the 5th. So there's multiplication of scientific notation numbers without necessarily using a calculator. Now, along with that, I want to look at, we'll take this problem just a step further here, and here's my example that I had. I want to take the number 2.4 times 10 to the 6th, and I would like to multiply that by the number 5.6 times 10 to the 5th. So in this case, if we were to multiply these, and following what we just talked about, certainly the calculator could handle this for us, but let's say that we attempt to do it without the calculator. We decide we want to multiply those 2 numbers right there, 2.4 times 5.6. Turns out to be 13.44 times, now we want to multiply these 2 numbers right here. Again, like basis, 10 to the 6th times 10 to the 5th, we should be able to add the exponents. So we have 10 to the 11th power. That is my answer, and it's certainly in scientific notation. It's just not in proper scientific notation. Proper scientific notation says that that decimal point should be located right there. It should be 1.344 times 10. And the question becomes, does this become a 12 or does this become a 10? I've moved it 1 over and I'm just not sure if I'm going to increase it by 1 or if I'm going to decrease it by 1. What I would remind you of is this. If we wanted to go back to where we started this lesson, if I take this times 10 to the 11th, that says that I should move this because it's 10 to the 11th, it's a big number. I should move my decimal 11 spots that direction. And that's going to make a fairly large number. When I move it back, if my decimal is way over here, when I come back, I'm going to have to go 1 more spot to get past here. So I hope that means, or hopefully you recognize that in this case, that's going to mean that I'm going to have 12 here rather than 11. And this should be my answer in proper scientific notation form. Now, let me jump down here and let's just talk quickly about division. And in this case, I'm going to use 8.0 times 10 to the 7th divided by 4.0 times 10 to the 2nd. And I used some numbers that I thought we could handle fairly easily. If we follow what we did before, guys, certainly you could plug these into your calculator, the graphing calculator will handle them for sure. The only thing I will tell you is this. You absolutely must put parentheses on your own around both of those numbers. We need this whole scientific notation number divided by this whole scientific notation number. And if you opt not to, if you forget the parentheses and you simply say 8.0 times 10 to the 7th divided by 4.0 times 10 to the 2nd, it only divides the 10 to the 7th and the 4. It's doing what you told it to do. We want the whole number divided by the whole number, so you have to insert parentheses on your own. But if we go back to what we talked about before as far as doing this by hand, we should be able to take this number right here and divide by that number. 8 divided by 4, and the reason I picked those numbers is we can do those. Turns out to be 2, I'm going to write it as 2.0 times, and now we want to divide 10 to the 7th and 10 to the 2nd. 10 to the 7th divided by 10 to the 2nd. Again, this is something we've been working on with our laws of exponents. In this case, we're dividing and we have like bases. The bases are 10. Hopefully you remember that our answer should be 10 to the 7 minus 2. When we're dividing, we have like bases, we subtract our exponents. So this turns out to be times 10 to the 5th. And that should be our answer. We got the 2.0 from dividing these, and we simply said like bases, let's subtract our exponents to give us our times 10 to the 5th. Now the last thing I've seen some of the students encounter is a problem maybe something like this, where it says how many times larger is 1.62 times 10 to the 9th than 2.7 times 10 to the 8th. And what I would ask you to do there is, that seems like a really difficult problem, and when you throw things in like, you know, the scientific notation numbers, it does get rather difficult. But if I change that problem and said, how many times larger is 20 than 5, most students, when I ask them that, they come up with an answer of 4. And my question to them is, how did you get it? And it's very basically 20 divided by 5. We took this number divided by this number. And if that's the case, we want to know how many times larger is this number than that number. We should take the bigger number divided by the smaller number. 20 divided by 5 gives us our answer 4. Well, if that works, then it seems to me that we should take 1.62 times 10 to the 9th divided by 2.7 times 10 to the 8th. And the only thing I would remind you of is if we use the calculator for this, we need to make sure that we put parentheses around both of those numbers when we type it into our graphic calculator. And when you do, I believe you should get an answer of 6. This scientific notation number 1.62 times 10 to the 9th is 6 times larger than the number 2.7 times 10 to the 8th. Again, I hope this short video helped you out. If you've got questions, be sure to ask your teacher. Thank you.